Right, to train them is my cause. 7.4, properties of logarithms. So just like exponents had properties, we're going to also have properties with logarithms, and you'll see that they're very similar to the properties of exponents that you already know. All right, so this one is called a logarithm of a product. If you have log base b of x times y, you can split up the x and the y so that it's log base b of x plus log base b of y. So if you want to split up the x and the y, it becomes a plus. Logarithm of a quotient. What do you think happens when you have log base b of x divided by y? They become log base b of x minus log base b of y. So the division turns into a minus. Logarithm of a power. So this one's a little bit weird because you have an exponent up here. Its property is that the n goes in the very front and you multiply it with log base b of x. Okay, so that n that's in the exponent, you just bring it down to the front. How about the identity property? What happens when you have log base b of b? So when the base matches the argument, we just have that equal to 1. All right. All right, let's go ahead and do some examples using those properties. Write as a single log. You have log base 5 of 8 plus log base 5 of 2. In order to put those two logs together, it becomes log base 5 of 16. You multiply the 8 and the 2. Log base 3 of 12 minus log base 3 of 5, they become log base 3 of 12 over 5. And then this last one, you have 3 times log base 2 of 4. It doesn't save any logs when you change this, but all you got to do is bring that 3 to the exponent, which is log base 2 of 4 to the third, and then you evaluate 4 to the third power, and then you get log base 2 of 64. All right, so that's just simplifying some logs, and that last one actually simplifies a little bit more, but we'll get into that in a little bit. All right, some tricky ones. Simplify that. So it's a whole bunch of logs, but what you can do is this 2 will go up here, which 3 squared is 9. Oh, I jumped straight to the answer already. So 9, and then since it's a plus sign with a 6, that gives us, multiply them together, you get 54, and then this minus sign means divide. When you divide by 2, you get log base 7 of 27. I just jumped straight to the answer real fast there. Here's another one. This one doesn't have a lot of numbers, but it has a lot of letters in it. Bring the 3 up here. Bring the 4 up here. Ooh, that was fast. Plus means you multiply them, and then minus means you divide. So this is in the denominator, and then these two guys are in the numerator. And then you can simplify this a little bit more when you have z to the third over z to the fourth. Final answer, log base b of y over z. All right, so that's just condensing a lot of the log properties together. Let's do the opposite now. What if I give you one log and I ask you to expand it out? Because that might be useful too. Take one log and then turn it into a whole bunch of logs. Let's look at the first one. I can come straight to the answer. The 2 that's up here goes to the front for the x. The 3 goes to the front for the y, and it's separated by a plus sign because they are multiplied together. and then this divide means subtract by z, log z. All right, so that's expanding them. Here's another one that's a little bit more complicated because it's got roots in it. Hopefully you guys remember the square root can be written as an exponent 1/2 power. So remember, the square root is the same thing as the 1/2 power. Now that we have that, we can actually do a lot of stuff with it. Give that 1/2 to everything inside the parentheses. And now we have 3 terms we can split it up to. 1 log for the 5, and then another log for the 2, but what I did was I brought the 1/2 to the front. That's why it's right here. And then same thing, 1 log for the x, but then I put the 1/3 to the front as well. All right. There's one thing that you can do in this problem, and it pertains to the middle term. Hopefully you guys remembered that this was a property. A log base 2 of 2 was just 1. And so there's our final answer. The 1 is part of the 1/2 in here. So 1 times 1/2. Okay, let's move on. Using brain power to evaluate some of the properties. All right, so we have log base 2 of 64 minus log base 2 of 2. Let's go ahead and combine those two logs together. They are a minus sign. So you would divide 64 divided by 2 is 32. And then you have to think to yourself, we did this lesson the other day. Log base 2 of 32. 2 to the what power gives you 32? And you have to think using your brain power. 2 to what power gives you 32? And it's 5. You could have done that separately too. You could have done the log base 2 of 64 first, and then do the log base 2 of 2 second, and then subtracted them as well. So that method works as well. Here's another one. It looks a little bit more complicated. Let's try to simplify it by bringing it down to just 1 log. The 1/2, remember, goes to the exponent spot right here. And then, of course, the 1/2 exponent is the same thing as square root. We know the square root of 81 is 9. Bring those two logs together. When you combine them, 9 times 9 is 81. And then you have to use your brain power. 3 to the what power gives you 81? 3 times 3 times 3 times 3. So 4 times. Final answer is 4. Let's grab your calculator for a second. Here's mine. We're ready to use. Oh, mine looks like the one in the picture. Nice. Okay, your calculator will actually do log base 10. Okay, if you look at your calculator closely, the log button is right here. It's hard to see in the photo, but you can see on your calculator that's the log button. And you can always use that button, but it only does log 10. And you don't have to put log base 10, you just push the log button and then 10,000. And the answer is 4. You could have also done that in your head. 10 to the what power gives you 10,000. But this one you could not do in your head. 10 to the what power gives you 355, and there's no way you can do that in your head. So your calculator will do it for you. You just push log of 355. And the answer is approximately 2.5502. And then your question might be, well, how does your calculator do it if it's not base 10? In this case, it's base 4. You can't do this in your head. You can't go 4 to the what power gives you 100, because your brain can't really think that way. And so your calculator will do it, and there's a couple of ways it'll do it. If you have a newer version calculator, by newer I mean within the last 3-4 years, maybe 5 years, if you go into, there's a button up here called Math, right here. It's the Math button. If you push the Math button, and then you scroll down until you see something that says log base. So if you have a new calculator, go to the Math button and scroll down until you see something called log base. If you do that and you click on log base, it will do a base 4, or it will do any base for you. But for those of you guys who do not have a new calculator and you have one of the old ones that doesn't have that function, we have what's called, oh, and there's the answer, by the way, 3.3219. But if you don't have a log base math button, we have the change of base formula. So you can actually change the base from any base to base 10 using this formula. So the formula says, let's say you have log base b of a. You can actually change it to base 10 by doing a division problem. The a goes on the top, and then the b, the base that was there before, goes on the bottom. And now we have a log base 10 problem. So let's do an example. Let's say you had an older calculator and it did not have that log base function on it. What you can do is you can change this formula so that it's log of 62 divided by log of 5. And now you can do it on your calculator because now they're in base 10. I know I didn't write the 10, but whenever it's not written, then it's always considered base 10. So you do log of 62 divided by log of 5, and it gives you 2.5643 approximately. All right, last present for the day. All right, this is our last present for the day. We have special properties. The first property right here, you have log base b of b raised to the a power. We saw this earlier where it was 1 and it's still 1. But with the a there, this whole thing just goes away and it reduces down to the a. The other one, b raised to the log base b of a, whenever you see these together, they also go away, and this problem reduces down to an a as well. Let's see how that works in some examples. 7 raised to the log base 7 of 5. Here it is. Those go away. We have the answer is 5. Log base 3 of 3 raised to the 5th power. The 3 base 3 goes away. Answer is 5 again. This one doesn't look like it fits the property, but we can rewrite 125 a different way. 125 is the same thing as 5 to the 3rd power. And now you see that this is the property, it goes away, and our answer is 3. Same thing with this one. The 1/9 doesn't seem like it would fit the property, but 1/9 can be written a little bit differently. Are you ready? There it is. 1/9 is the same thing as 3 to the negative 2nd power. This goes away. Final answer is -2. And our last one, this one's just a little bit more complicated. You can rewrite this 9, so it's 3 squared. And now this goes away. And over here, this goes away. And we have just 2 plus 7 equals 9. All right? So that's a lot of properties with logarithms. It's thrown all in one section, and so hopefully it doesn't confuse you too much, but go ahead and practice the homework with them.